Welcome back. In this lesson, we're going to look at changes in the climate, normally over a very extended amount of time, lots and lots of years, for various reasons. Why would an area that's normally has lots of moisture, why would it go dry? Or why would something that would be normally warm go cold? That has happened over Earth's history, and we'll see some of the reasons for it today. So climate is already over a broad area in a long period of time, so an extended period of time rather than, say, an afternoon or a day. It's over a century or over a long extended period of time. But within larger periods of time, so over many centuries or over many thousands of years, it is very possible that what once was a very moist place on the earth would become very dry. So there was a time where there was living things in the Sahara Desert. It was still a warm place, but there was lots of things growing, that now it's a very dry. So whole weather patterns have changed. And as they've changed, you end up with new climates in new areas. Now that usually takes extensive amounts of time, long periods of time, and that's kind of what we're looking at now, is these big constant changing of the climates over a period of time. So the first thing we're going to look at is ice ages. There's evidence that the whole North America and most of Europe has been scraped by huge glaciers, and the northern part, down to about Ohio, middle of Pennsylvania. That's about how far that the ice went during the last ice age. And then there's been cycles of colder and warmer temperatures over a large period of time since then. So an ice age normally is whole global temperatures have dropped by a few degrees, 5-10 degrees, over the entire, say, North America, and then glaciers that would have developed in the far north can go further south because the temperature is more the way that it would be in, say, northern Canada. If Wisconsin is as cold as northern Canada, then glaciers would not melt there, and they would just continue to grow. So an ice age is when you have a cooling of the planet, the middle latitudes away from the poles, and then you have ice that's extending from the poles down far down into those latitudes. Now, easier than ice age is just the idea of short-term climate. You know that it snows in the winter and usually doesn't snow in the summer. So the seasons are a climate change. So the seasons are caused by the tilt of the earth. So if you'll look here on the pictures, you can see that at the equinox, this is the spring equinox, the light is even over the north and south of the world, okay, over the globe. So the northern hemisphere and the southern hemisphere are getting the same amount of light. You're going to see that that's the same in the autumn. So here's the autumn, and you're going, let me bring this up a little bit, okay. So in the autumn, you're going to have the north and the south that's equal light, so the same amount of light is on the north and the south during the day. But in the summertime, you're going to have more in the northern hemisphere and less in the south. So the sunlight doesn't even go all the way to the South Pole in the northern hemisphere summer, and it doesn't go all the way to the North Pole in the southern hemisphere summer. So you're going to see that there are 4 distinct seasons. So this is spring, and then this is our summer in the northern hemisphere. This is fall, and this is our winter. And you can also see that during the winter of the northern hemisphere, It's the summer of the southern hemisphere. So the two hemispheres, north and south, are opposite each other, and it basically has to do with the tilt of the Earth. The Earth is not straight up and down, so the sun is not equal to the equator. It's not on the same plane as the equator, but there's a tilt to the Earth, and as the Earth goes around the sun, that tilt will appear to move from one side up to normal to the other side. Okay, what's actually happening is the whole Earth is going around the sun. The Earth is not moving side to side, but the entire Earth as it goes around. So it takes 3 months to go from spring to summer, and then 3 months from summer to fall, etc. So the next thing that is interesting and rather difficult is that the oceans control climate a lot, very seriously. And if you can have changes in the temperature of the water in the oceans, especially say the Pacific Ocean, which is the widest stretch of ocean, then you can change the weather patterns all over the world. All right. So normally, if you are talking about the equator, you are going to have descending dry air coming on the west side of South America. That means it's going to be usually a dry climate. So if you were to look, say, in the Andes Mountains, which is along the western coast of South America, those are very dry areas. You don't have lots of rain there. So because of that, you end up having a upwelling of cold water on the west coast of South America. And then you get a surface current that goes all the way across the whole Pacific Ocean. Well, when that happens, you're going to have winds that are going to be pulling across, and then that is picking up hot water, and then as it picks up hot water, then that hot water rises, and then that rising hot water creates storms. And so generally or normally, you are going to have lots of humid, rainy weather in the west side of the Pacific Ocean around the equator. So that would be, say, Indonesia, Bali, Borneo. And so that's normal. You would have lots of rainforests in those areas. You don't have rainforests in western South America, but you do have rainforests in the islands, South Islands of the Pacific Ocean. Okay, that's normal to have that. So in a normal year, that is where you have upwelling of cold water, you have surface currents, and you have the currents in the ocean and the currents in the air that generally makes it dry on South America and wet in East Asia. Okay, that's an El Nino. La Nina, which is opposite, normally has cold water coming up on the other side of the ocean, which changes the rainy season. So it's not so rainy in Southeast Asia. So, Laos, Cambodia, Vietnam, it's not rainy there. It's dry. You get drought conditions, and then you get a wetter area in South America. Now, that might not seem like a big deal. Okay, so it rains sometimes when it didn't rain normally, and it doesn't rain when it does. But the amount of heat that the oceans control and humidity that the oceans control mean that a change in these ocean temperatures changes the weather for the entire world. So when you have an El Nino event, you might have a drier, colder winter in North America, but you will have a wetter winter in another place. Okay, so it just basically monkeys with all of the weather patterns. So La Nina is an opposite, where you're going to have an upwelling on the west side rather than the east, and then as that goes around, you're not going to get as much wet weather on the west. You'll bring it to the west coast of South America. Another thing that causes big differences in weather is sunspots, and it's strange that would be connected, but when you have low sunspot activity, you usually have cold ocean water. And when you have lots of sunspot activity, then you're going to have normally hotter water. So when people have started, just astronomers, looking at sunspots, which are dark spots, basically storms on the sun, and these storms are creating conditions that actually affect the weather on the Earth, then you can, if you were to mark the temperatures during sunspots, okay, then you can, and then take them over year after year, and then go back in time, you can see that very low sunspot activity has actually coincided with a very cold time in world history. From the 1600s to about 1750, that was a very, very cold time. In fact, there was lots of crop failures in Europe. It helped people want to actually go to another place. So like there was migration issues built around these weather events. Diseases that would have not been there had it not been just a wet, miserable, cold winter over a long period of times, and even cold, wet summers. So these sunspots do have effects in not just temporary weather, but long-term weather as they go in cycles. So there's sunspot cycles where you have lots of sunspots and then fewer, and then lots and then fewer. And then in areas where you have very low, you could have very cold temperatures. That over a long period of time, you would get a climate change. The Earth's orbit is seen to change over a long course of a cycle where it becomes more elliptical rather than more circular. That can change the climate. There's also the tilt of the Earth can become more extreme or less extreme over a long period of years. That could be a reason why that over the course of Earth's history there have been some differences in climate. The wobble of the Earth as it's spinning on its axis is actually moving in space slightly. That changes it. You can even have something like a volcano, that the dust in the volcano would actually block the sun to the extent that the entire temperature of the Earth could actually drop. So there are various reasons why over the long period you may have differences in